so we live. So this is parallel lines and transversals notes. The first term here is a transversal, new term for y'all, but you're gonna hear me talk about it a lot from now on, now that I'm teaching it to you today. A transversal is a line that intersects two or more lines. So up here in this image, this line right here that I'm gonna highlight for you, line looks like T, would be considered a transversal. It's a line that intersects two or more lines. So next example, we will write line T. Also, before we get going too far, things that'll be handy for y'all during these notes: highlighters if you have them, color pencils if you have them, different color pens if you have them. I'm be color coding my stuff just so you can see, but you might want to color code your stuff too. But those are things that would be handy if you had them. If you don't, it's all good. You might work without it. But if you have those things, I would suggest you use them. Alright. So down here, we have angles formed by a transversal. These are new angle pairs that I'm teaching you today. Now, you already know some angle pairs, and they still will come into play. Angle pairs that you've already learned in this unit. You've learned about adjacent angles, what is it? Supplementary angles, complementary angles, a linear pair, and what's the other one I'm missing? Vertical and vertical. The main ones that are still coming to play for us right now is vertical, supplementary, and then linear pair. Adjacent, yeah, these you have adjacent angles in this figure, but that's not going to tell us anything about the angles other than they sit next to each other. They're not going to tell us about congruency or anything. Complementary won't really help us on here either, because it's never really right angles in these situations. Sometimes it can be, but most of the time it's not. Alright, so down in the diagram, they show you similar to what you saw at top, two lines being cut by a transversal here. This transversal is still T. Now we just put numbers on the angles here. And then we're going to talk about angle pair relationships here. The first angle pair relationship that they want you to know is corresponding angles. Corresponding angles are angles on the same side of the transversal. So let me highlight my transversal again. Over here, man. Corresponding angles are angles on the same side of the transversal and in the same position. So they'll be on the same side of that line that I highlighted, and they'll be in the same position. Those will be corresponding angles. Same position mean like one is on top of the line being intersected, the other one will be on the other top of the other line being intersected. One is on the bottom of the line being intersected, the other one will be on the bottom of the line intersected. So an example of I'm going to give you examples of the corresponding angles. I'm going to indicate one on the actual figure, and then I'm going to write all of them on to the side. So on the figure here, angle 1 that I'm marking in red, and then angle 5 that I'm marking in red as well, would be considered corresponding angles. So angle 1 and angle 5 would be considered corresponding. After that, on that same side, angle 4 and angle 8 would be considered corresponding angles. Angle 4 and angle 8. Then angle 2 and angle 6. And angle 6 And then Jeremiah, what's the last pair? Angle 3 and angle 7. Those will all be considered corresponding angles just because of the position they're in. Same side of the transversal and the same position. Corresponding. Next one. Alternate interior angles. Alternate interior angles. The area I ask my kids to think of these words too. I'm going to read the definition first, but then. So interior angles, non-adjacent angles on the opposite side of the transversals. So they're non-adjacent, meaning they don't sit next to each other, and they're on the opposite side of the transversal. What's the word interior mean? Somebody? Louder? Inside, right? So when they say inside, they're meaning in between these two lines that are going in the same direction, pretty much. They're not quite parallel. They will be on the back. But these two lines are going in the general same direction. In between there is the inside area. Outside of that would be considered outside. So this area in here would be considered interior. They're saying the angles are alternate interior angles, though. They alternate over the transversal. And when I hear the word alternate, I think of switch or flip or something like that. So they're on different sides of the transversal, but they're non-adjacent too. So I'm going to mark a pair of alternate interior angles for you. I'm going to do those in green. And I meant to put a little key up here. Did those in red. I'm doing this in green. So angle 4 and angle 6, I would consider those alternate interior angles. Angle 4 and angle 6. And there's one more pair of alternate interior angles too. Billy, you know which ones?
Yeah, angle 3 and angle 5.
Thank you. Angle 3 and angle 5 are the other pair of alternate interior angles. Alright. Next, alternate exterior angles. Sounds familiar. Exterior angles, non-adjacent, on the opposite sides of the transversal. So exterior, meaning outside. Alternate, meaning they flip over the transversal. Rama, I'm going to let you stop me on this, and I'm not even going to tell you what you think of as a pair of alternate exterior angles. Huh? Yeah. Yeah. I'm doing this in blue. Go ahead, Lucas. Perfect. Those are the ones I was going to pick first because I need a angle 2 and angle 8 are alternate exterior angles. Alternate over the transversal, they're on the outside. Alternate exterior. It's all in the word. 2 and angle 8. Alright. What's the other pair? Angle 1 and angle 7. And then last but not least, we have consecutive angles. Now before we even start this, consecutive, it depends on who's writing or who's asking you the question. They also, and I want to add this in first before we even do anything else, put in parentheses on top. Another word they use for consecutive, they call same side interior angles. You'll even see it as consecutive angles, consecutive interior angles, or you'll see them as same side interior angles. They all talking about the same thing. They even have the word same side in the definition for it. But sometimes they just call them same side interior angles. But they could, I mean, most of the time they say consecutive, but they switch it up. That's the weird one. Anytime they talk about either consecutive or same side, though, they're talking about the same thing. Yeah. Alright. Consecutive angles. Interior angles that are on the same side of the transversal. Or consecutive interior angles, excuse me. Consecutive interior angles that are on the same side of the transversal. So for this one, I'll hit the first one. Interior angles inside on the same side of the transversal. So I'll be looking at angle 3 and then angle 6 for this one. 3 and 6 will be considered consecutive interior or same side interior angles. And then the other pair should know it's angle 4 and angle 5. We're going to see how much you digested of that just now. I'm about to make my way around the room. So down here, using this as an as a kind of a key for us. Down here it says example 1. They want us to name all these angle relationships based on the angles that they call out. Now, before we do that, a couple things you need to notice. On this one, it looks a little different than the one up here. Up here, you just had two lines being intersected by one transversal. Now you have, and we usually call this a hashtag too. Sometimes y'all gonna see these a lot. These are the ones we like to hit y'all with. It looks like a lot more, but all you gotta do is single out what you're looking for. An important note down here before we start: for you to compare an angle pair, angles must belong to the same transversal to be an angle pair. If they don't belong to the same transversal, then the angles have no relationship. That's an important thing, and you might want to highlight that for yourself too. For angles to even have a relationship, they must be on the same transversal. If they're not, you don't even need to compare them. Alright. So, but depending on the way you look at this, and I'm talking to all y'all, depending on the way you look at this, you got 4 different transversals here. So say I'm just looking at these numbers over here on this transversal A. Then I'm only considering that, it got C and D that's going through and transversal A cutting this way. But then I could be looking at the numbers here on transversal B right here and comparing those relationships. But then, depending on how they call it, if you want, and you can turn your paper too if you need to. I'm just trying to show you. Looking at it this way, C is a transversal, and then you got angle pair relationships on here, and then D is its own transversal here, and you got angle pair relationships here. So it's depending on the way you look at it. It's gonna be a little rocky start, but I think y'all catch the hang of it. You just need to pay attention. Timothy, angle 5 and angle 13.
Corresponding angles?
Alright, he was ready. Okay. Yeah, good. Angle 5 and angle 13. If y'all looking at those and stare at them for a second and look up at your notes if you need to, that we already took, these are corresponding angles. So corresponding, let's wrote corresponding over there. Then Tylee, angle 7 and angle 14. Perfect. Y'all doing good so far. Angle 7 and angle 14, they're on the same transversal B right here. So they're alternate interior angles. They're interior on this one. At some point I'm going to start abbreviating, but we're going to write everything out for now. Alternate interior. But at some point I do abbreviate these relationships. Y'all see me. Bailey, angle 3 and angle 6. So Billy, and I kind of gave you a more difficult one than I gave these two. On this one, this is where you might need to rotate your paper. Well, let me ask you this first, Billy. What transversal are angles 3 and angle 6 on? C, right? So for me, just so I can see it correctly, I might turn my paper this way. Who can help Billy out? Emra, go ahead. Alternate exterior angles. Thank you, sir. Perfect. If you turn it this way, you should see that this is the outside. This is the outside here. And so these are exterior angles, alternate exterior, based on the way you call them. Like I said, it's based on the two angles that we're talking about. So alternate exterior. Next one, angle 9 and angle 16. Devin? Angle 9 and angle 16. Yeah, alternate exterior again. Y'all should see that those are on transversal D. Might be giving her a hard one, but I'm gonna try anyway. Zoe, angle 4 and angle 7. Not quite. Just Savion?
Consecutive interior.
Yes, these are consecutive interior angles. What transversal are they on?
C.
Thank you. So consecutive interior. And make sure you remember we can also call them same side. So consecutive. I don't know, I always have a hard time spelling that. Interior. And then in parentheses, I'm going to put same side. Just as a reminder for y'all. Because I just don't know. It depends on who's writing your question, what you're going to see for that one. So stay tight. I'm going to come back. Who is that up front? I can't see everybody. Vince. Angle 2 and angle 10. Jorge, angle 2 and angle 10. Corresponding angles. What transversal are they on, Jorge? Thank you. It's a good Rama one. Angle 8 and angle 14. Angle 8 and angle 14. Oh, this wasn't a good Rama one there. Never mind. This was the next one I wanted for you. But I'll take it anyway. Yeah, consecutive interior. I'm looking at the next one. My bad. Consecutive interior or same side, 8 and 14. What transversal are they on? Just checking. Thank you. Maybe I ask Jalen this next one then. Angle 6 and angle 11. So what's up? Oh, yeah. No relationship. You could literally just write that. No relationship. Victoria, angle 4 and angle 13. Say it again. Good. No relationship. I know some of y'all might think corresponding or consecutive, but those not on the same transversal either. And then the last one, angle 4 and angle 9. Zoe, I come back to you. Good. Alternate interior. Alright. We're going to pause right there. Alright, we're back. So on the back, we're looking at parallel lines and transversals. This is the back of our notes. It says, if two parallel lines are cut by a transversal, then you should know these things about your angle pair relationships if two parallel lines are cut by a transversal. The first thing you should know is each pair of corresponding angles is congruent. Each pair of corresponding angles is congruent. I'm going to highlight my important words too. So all y'all need to know, corresponding angles are congruent. Each pair of alternate interior angles is congruent. Each pair of alternate exterior angles is congruent. Here's where the switch happens. Each pair of consecutive interior angles, and we need to add in the word same side again. Let's parentheses, put it on top. Same side. It's supplementary. Supplementary meaning what, Jeremiah? I always seem to ask you, but I like asking you. Don't just blurt it all out. Supplementary meaning what, man? Not necessarily that it'll be a linear pair. Go ahead, Jasavian.
Two angles that make a straight line.
No. Go ahead, Rama. No, that's an obtuse angle. Supplementary angle. Y'all, we just did this the last set of notes. Y'all tripping. It ain't an angle. It's two angles. These are angle pair relationships. Two angles that equal 180. And I've taught you this and you think you're right. You're confident in that. You said I said a straight line. No, listen. No, you want to talk, so I'm going to educate. Shh. Do supplementary angles always have to form a straight line?
No.
I've told y'all that. And on here you're going to see that the supplementary angles won't always form a straight line. For example, they say consecutive angles are supplementary. That means on this figure right here, angle 4 and angle 5 are supplementary. Do those form a straight line? They're not even connected. Yeah, some of y'all gonna say yes, but those two angles aren't even adjacent. Angle 1 and 4 form a straight line. Angle 4 and 5 aren't even connected. They're not adjacent angles, but they are supplementary just because they're consecutive. Last thing, and that's stuff you need to remember. Here you go. Recall, vertical angles are always congruent. Vertical angles are always congruent. You should already know that though. And then here goes the straight line right here that y'all keep wanting to tell me about. A linear pair is always supplementary. That equals 180 as well. I'll wait till we get there to show you. Do we do any? No, we don't do any on this one. So I'm gonna actually show you now. I like showing kids why consecutive angles are supplementary, even though they're not connected. So follow with me for a second. I think it's a good time to do it at the beginning. Just by looking at the angles themselves, looking up here at the diagram, would y'all all agree that angle 1 and 4 form a linear pair? A straight line? Yeah, right? Between those two angles, I should know I have 180 degrees because they form a line. They're not congruent, but I know they add up to 180. Now, let me ask you this. Would you also agree that angle 1 and angle 5 are congruent?
Yeah.
Angle 1 and angle 5 are the same, right? So whatever angle 5 is, angle 1 has to be. So say I don't know angle 1, but I know angle 5. I can still assume that angle 5 and 4 are going to add up to 180 because 1 and 4 add up to 180. And angle 1 and 5 are the same. Those who with me, y'all follow what I just said? That's why we know consecutive angles are supplementary. Because even though these two angles here don't form a straight line themselves, I know angle 1 and 5 are the same. And if angle 1 and 5 are the same, then if angle 1 is supplementary with angle 4, then angle 5 has to be supplementary with angle 4. I think that was a good way of saying it. That should make sense to most of y'all. But yeah. Alright. Example 2. It says given angle 1 is, the measure of angle 1 is 65 degrees. Find the measure of each missing angle. Give your reasoning. So, and you're going to have to do this from now on for me too. We're going to find the measures of the angles, but we're also going to tell why we know those angles are what they are. We're going to tell their relationship. So, and there's multiple ways of doing it. I'm going to just go with whatever y'all tell me. But the first one, they tell us angle 1 is 65 degrees. We should go ahead and put that in on our figure. We know that angle right there is 65 degrees. Why they told us? After that, we want to find angle 2. Timothy, go ahead.
I got 115.
Yeah, angle 2 would be 115. Everybody, well, before we explain why, we could just tell the reason. You said 115. What's the relationship between angle 1 and angle 2 that let you know that that was 115 degrees?
I knew it was going to make a straight line.
So what we call that?
Linear pair.
Linear pair. So we knew angle 1 and 2 were a linear pair. And then the other thing you were about to say, you're going to say supplementary, right?
Yes, sir.
So that told you that they were going to add up to 180 degrees. So all he did to find, for those who don't realize it, all he did to find angle 2 was subtract from 180, since he knew they were going to be supplementary. Sliding back over. So 115. Alright. So now I got angle 1 and 2. They want angle 3 next. There's multiple ways to figure out angle 3. I'm going to go with whatever y'all say. Actually, I want this one a certain way. There's multiple ways though, but I don't want to use the same thing I just used. So to figure out 1 and 3, let's look at this. Angle 3, let's look at the relationship between angle 1. Angle 1 and angle 3, let's talk about that first. What's the relationship between angle 1 and angle 3? They're vertical angles. What should you know about vertical angles? Alright, so what would angle 3 be? Yeah. Now, you could have went the vertical route, or you could have talked about the relationship between angle 2 and 3. You see, 2 and 3 have a relationship too, right? What was that relationship? Somebody, anybody. What was you could have went the vertical route like I went, but you could also talk about a relationship between angle 2 and 3 and found angle 3. What's the relationship between angle 2 and 3? Linear pair. So you could have went that route too and still got 65. Multiple ways to do this now. So we said angle 3 was 65. Then they want angle 4. I mean, what's the relationship? Let's go the easier route. What's the relationship between angle 2 and angle 4? What's the relationship between angle 2 and angle 4? Yeah, I was asking Jameen, but thank you. Thank you, Devin. They're vertical. So yeah, we should know that that angle is 65 degrees as well. I mean, not 65. Who told me that? Why, boy, y'all about to mess me up. Y'all messed up my paper. 115. I said, hold on, that's obtuse. It can't be 65 degrees. That's another thing, too. I'm glad that kind of happened, because it's something I like to tell y'all all the time, too. Like, on these, use common sense. Most of the time, these are drawn accurately. Well, not accurately, but drawn the way they're supposed to look. Like, for me, even though somebody said 65, like, looking at this before I wrote, well, after I wrote it, this angle 4 look like an obtuse angle or an acute angle. So it wouldn't make sense to put anything less than 90 on that angle, right? I'm asking. I asked y'all because I need y'all to use common sense on these type of problems. Like, it wouldn't make sense on this type of problem. Like, even for angle 1, it wouldn't make sense to put anything greater than 90 degrees. It's an acute angle, yes? Y'all can look at that and just know what range you should be in, at least. Alright. Angle 5. For that one, what did I want to use? Let's keep going with angle 1. The relationship with angle 1. Angle 1 and angle 5. To find that, let's talk about the relationship between angle 1 and 5 first. Hold on, I don't want you answering every question. Hit some of these other folk. Jorge, what's the relationship between angle 1 and angle 5? Corresponding angles. Good. You should know corresponding angles are what? Congruent on parallel lines. So if that's the case, what's the measure of angle 5?
65.
I was asking Jorge still, but thank you. I'm trying to hit everybody, man. I don't want the same people answering all the questions. Some of y'all be hiding in here. Vince. The next one, we want angle 6. What'd you use to figure that out? You hit, huh? Well, let me ask you this, Vince. Let me set you up. What's the relationship between angle 2 and angle 6? No, that. What's the relationship? I know that it's same. What's the relationship that lets you know that? Been doing this for about an hour now, man. Go ahead, Emma. Corresponding angles. So they said 115. Billy on number 7. Not the angle so much as the relationship. What's the relationship between angle 1 and angle 7, Billy? I can't hear you. I didn't hear the last part. Thank you. Alternate exterior angles. Those supplementary or congruent, Billy? Okay, so what's angle 7? Thank you. Last one, angle 8. I'm going to have y'all compare angle 5 and angle 8. I'm just making my way around because I want y'all to compare different angles. I don't know what you're talking in here. Jalen, what's the relationship between angle 5 and angle 8? Say it again. Yeah, they are, but what else are they? Who? I'm gonna make this hard, Jalen. Rama, what's the relationship between angle 5 and 8? No. Linear pair. They are supplementary, though. That's the thing you should know after linear pair. So angle 8. Guess I'll tell myself 115 degrees. So the main thing you need to look at on here is kind of recognize the pattern of this when you have the parallel lines. When you have parallel lines and you just got one transversal, on that transversal you're going to create two different angles, an obtuse angle and an acute one, unless it's perpendicular. Then they'll all be 90 anyway, and there ain't going to be no use in calculating nothing. But in this case, you're going to create an acute angle and an obtuse angle, and they're going to flow like that. It's going to be pretty much your pattern. And then the other thing, you just need to notice that little arrows here indicating parallel. Now sometimes they'll ask you to prove if a pair of lines are parallel to each other by like finding the angle measures. Well, actually, if two transversals are. Sometimes we'll do the double hashtag, and then you'll find all the angle measures on both. And if they don't all match up, then the lines aren't parallel. Like if all the angles match up, that's how you know the lines are parallel too. Last part, let's do some algebra. That's what we need to get to. I told you the end of your notes is always the most important part. This is where we was heading the whole time. We just had to make our way around learning relationships. So now that we know angle relationships, let's do some algebra. Directions. If line L is parallel to line M, find the value of each missing variables, plural. Because on our last one, if you look number 6, we have an X and a Y that we have to find. That's fine. That's easy to do. Identify the relationship. So all I'm gonna do for y'all on these, I'm gonna do setup with you. First thing on these, they told us at the top that they were parallel instead of like on the first one up here that we did. They indicated that the two lines are parallel. In this case, they're just telling you up top. So if you want a 2 on your line, you can just indicate parallel on your lines when you start. So L and M are parallel. That being said, they want us to solve for X on this one. Before we solve for X, the most important thing I want y'all to do, and all y'all have to do this, I want you to identify your angle relationship first. And before you solve any of these problems for me, you always gonna write your angle relationship first, so I know that you know what your angle relationships are. On this first one, Rama, is what's the angle relationship? Corresponding. First thing you're gonna write for me before you write your equation is corresponding, just indicating to me that you know what your angle relationship is. Then after that, since they're corresponding angles, Rama, to solve for X, what equation would I write? You sound like you're guessing. If two angles are corresponding, what do you know about those angles? If two things are congruent, what can you do with them? Okay, so let's go with confidence and say what our equation is. Thank you. So y'all know I'm not solving that. What again?
That's the same.
Who?
That's the
It probably is. I don't know, Billy. I'm not solving it.
It is.
Okay, well, yeah, that sounds good.
When you look at it, use common sense.
Yeah, you can.
Equation.
Well, you still gonna solve though. You can't use common sense on all these. Oh, okay, so you got number 6 too, huh?
No, I haven't done three.
Oh, okay, so you didn't. Number 4. Was that our next one? Yeah, number 4. On this one, 2 things. They're showing you parallel here and here, and then here, and you'll see us do this sometimes. Sometimes we don't have enough space to write our expression on the actual angle, so we'll actually write our expression outside somewhere and then use an arrow to point to the angle that we're talking about. But the 2 angles that we're comparing are this angle right here and this angle right here that has 125 on it. These are the 2 angles that we're comparing on this one. So that being said, Ty Lee, what's the angle relationship between those 2 angles that I just marked? Alternate interior. And from what we said, and this one I'm going to start abbreviating, y'all. For alternate, I'll start using alt. And then interior, I'm going to just say INT. So for alternate interior angles, we know what about their relationship? Yeah, that's what I'm trying to get Tylee to say. On the back, Tylee, it says it up top. Alternate interior angles are congruent. That being said, these 2 angles are congruent. Tylee, what equation are you going to write? Yeah. I'm sure y'all solved that one by now. Moving on. Alright. Number 5. L and M are parallel. On this one, you got an angle right here that they put an expression on. And you got an angle right here that they put an expression on. Jeremiah, what's my angle relationship? Alternate exterior. What do you know about alternate exterior angles now? So what you writing? Good. Now I don't want y'all to think all of them are going to be set equal to each other. That's why I want to get to number 6 at some point. For the majority, if you look up top, most of our stuff is congruent. But if you run into consecutive interior angles, those are not congruent. If you run into a linear pair, which you will, those are not congruent. Solve this one right quick because I'm trying to get to number 6. So, alright. I should be good on that one. I'm close to good. So the last one. Gotta solve for X and Y. Now, I'll tell you, and a lot of times when you do this, one thing is usually dependent on the other. If you look, I have two expressions for X on here. So I got two angles that I can compare for X. But I only have one angle that I can compare for Y. So Y in this case is dependent on me solving for X first. I gotta solve for X first, and then I gotta figure out what to do with my Y. So let's talk this way first. I see my expressions for X here and here. Timothy, what's the relationship between those two angles? Alternate interior. So what equation would I write to solve for X?
8x minus 31 plus 6x plus 3. I'm not sure what that would be equal to.
Oh, you said plus 6x minus y. Alternate interior angles, you think they add up to what?
180.
Who told you that?
Nobody, I'm trying to think.
What did it say up top, Timothy?
They're congruent.
So,
They're going to be the same.
so what's the equation?
8x minus 31 equals 6x plus 3.
Make sure I save room out here too, because we got more to do. I probably actually use too much room, but I'm fine. I'll make up for it. We need to solve for X first. Once we solve for X, I'll show you what we're going to do next. Emma, what we got for X?
224.
Something off.
Yes, sir.
Rework your equation, Emma. You shouldn't have got no decimal. You saving?
17.
Yeah. X equals 17. Like I said, I don't want to do algebra with y'all. I feel like y'all need the challenge. I think a lot of y'all just copy my algebra down and y'all never get to practice. Y'all need to start practicing. You know you should subtract 6, got 2x. Should got 2x minus 31 equals 3. Should have added the 31, got 34. And then you should have divided by 2. Would have got 17. Anyways, moving beyond that. I hope on your paper, some of y'all don't have all this blank and just wrote down x equals 17 like me. You should be solving these equations. I go through this every year with some kids. I'm not solving it for a reason, because y'all should know how to solve equations. I shouldn't be sitting here doing this with y'all every time. Alright, after that, so listen to my explanation. I'm going to try to talk slow at least. So now we know x equals 17. Like I said, our main issue on this one for the y they only got one angle on here with a y on it, so I can't set a y expression. I can't set it equal to an x expression, and I can't add a y and an x expression together and set it equal to something else. So I couldn't. There's nothing I could do with y until I found x. Because now that I found x, I can actually plug in and find my angle. And I know these two angles are going to be congruent, so I could plug into either one of these and get what these angles are going to be. Because they should be congruent to each other because they're alternate and stereo angles. Like I said, I always choose to plug into the easier thing too. The easier one to plug into for me on this one would be 6x plus 3 because it's a much smaller expression than 8x minus 31. Wouldn't you agree? I hope you would agree. Okay, so I'm going to do 6 times 17 plus 3. I'll do it out here. Out here, I'm going to just find my angles. 6 times 17 plus 3. You do that math, you should get 102 plus 3, and you should get 105. So you should get 105 degrees. So that means this angle in orange right here is 105 degrees. This angle right here is 105 degrees. Well, now that I know the value of the angle, now I can sit here and talk about a relationship. And you could look either way. Both of them are 105 degrees. So I could look at my relationship with y right here with this angle, or I could have looked at it with that angle. But I'm going to look at it with here. So for me, I know that this angle right here with the y on it and this angle now that I found that's 105 degrees, I know that those two angles are consecutive angles. Just from my angle pair relationships. I'm using the harder one obviously because I want y'all to see consecutive too. You could have looked at here and here and saw a linear pair. I hope y'all know that. You could have went this way and saw a linear pair. But up top, what should you know about consecutive angles and linear pairs? Both of them, either consecutive or a linear pair, both equal 180. So in that case, either way you look at it, you could have set your equation up. So now that I know that, I'm going to say, what is scratched over? That's a 5y? Yeah. 5y plus 35 plus 105 equals 180. This is one of my 180 equations. Say it again. Huh? Yeah. And I heard him say that too. Like, I don't want to teach kids like that because y'all gonna have to write 180 equations. Because you won't always know this value right here. Like for example, let me see if I got any. I understand what you and Tim just said, but I kind of ignored y'all because I don't want to teach kids that way. I know you could probably just set that one thing equal to 75 because you can subtract the 105, but you won't always know that value. So I don't want to set you up for failure.
I didn't know what you're talking about for a minute. I said that a while ago.
I don't even know what you said, bro. Let's see if I got a consecutive one on here. Like for example, and the stuff I have for you later. Right here, these x values right here are consecutive. But you're not going to know what either one of these values are, so you can't say, okay, I can set this equal to 75 or this equal to 105. You don't know either one of those, so you got to write the full equation out with equaling 180. I don't want to teach you something that's going to confuse you later. Alright, then you solve for y, and then find the value of y, and then you're done. X and y on that one. Made a long video here.